Good morning, my dear friends. Myself, Dr. M. A. Channaya, and in today's video, we are going to learn about the sections of solid. Friends, basically, you should know what is the purpose of studying the section of a solid, and this is particularly of importance to students of mechanical engineering, industrial engineering, and so on. Friends, the purpose of getting the section or obtaining the section of solids is to see the inner details of that particular solid or the component. So friends, in today's session, I am going to explain how to obtain the section of a triangular prism. Friends, basically in the sections of solids, you need to know exactly how to place the object initially. That is very important. Generally, when you do not place the object properly with respect to VP and HP, then you do not get any marks at all. So, you should first of all learn how to place the object. And in general, whenever any of these prisms are placed on HP or on dome, one of the sides, the shorter side, is kept perpendicular to VP, such that this side comes to your left hand side or a corner comes to your right, or it could be placed this way also depending on the problem. So friends, here in today's problem, I am going to explain about this triangular prism before I take up the actual problem. Friends, in a triangular prism, as the name indicates, it has got two triangular faces, one at the top and one at the bottom. They will give you the size of this. And remember, in a triangular prism, these two are equilateral triangles. The center of the top face and the bottom face, one is called O, other is called O1. And the imaginary line connecting these two is called the axis of the solid. Friends, any of the prism is surrounded on its lateral surface by a number of rectangles. That is, a triangular prism will have 1, 2, 3 rectangular faces on its lateral surface, and here the side of that rectangle will be the side of that, and the height is given by the height of the axis or height of the solid. So similarly, a square prism will have a square top, a square bottom, and that is surrounded by 4 rectangles. Similarly, a pentagon will have 5 rectangles, a hexagon, 6 rectangles, and so on. Friends, in today's problem, we have a triangular prism of sides, this is of 30 mm and 70, means this side is 30 and the height. So height of the axis, height of the longer edges, namely AA1, BB1, they are all same, each is equal to 70 mm. Resting on its base and HP with one of the on its square face is cut by a section which is normal to VP and inclined to HP, bisecting the axis of the prism. Friends, it is resting on HP with one of the shorter edge perpendicular to VP. So I will write down here with a shorter edge perpendicular to VP. So friends, let us see what happens when this is cut by a section plane. So basically friends, you have to keep the object in such a way such that one of the shorter edges is perpendicular to VP. Obtain its top view and front view. So friends, in the top view, you see an equilateral triangle of side 30 mm, and in the front view, you will see this rectangle. You can see this rectangle in the front view. In the top view, you will see a triangle which is equilateral. The bottom triangular face is covered by the top face, and as you see, only one. Now friends, it is cut by a section plane, all these details are given. So let me start this problem by drawing the initial front and top views of the solid. So friends, let me draw to start with the initial position of the solid. That is, I just mark this xy line representing the intersection of VP and HP. So I will mark it as xy, the line of intersection of VP and HP, and I will write down here VP by HP, indicating the first angle projection. So I am solving this problem using first angle projection. Friends, they have given us a triangular prism. The side is also given to us. So the side of this is 30 mm and we can just mark it. All the sides are 30 mm. I will just mark it as A, B, C. And I locate the center by bisecting any two adjacent sides like this. You get O, the center of the top face, O1, the center of the bottom face. Friends, from here in the front view I showed you, you are getting a rectangle. So I will just write a rectangle here. So friends, the height of this rectangle is equal to 70 mm. So I have drawn the front view and top view of the triangular prism, in which one of the side, the shorter side, is perpendicular to VP, and I have got the front view and top view of this solid. So this is O dash and O1 dash, the center of the top and bottom faces. So let me see how to mark them. So friends, marking is also very important, and if you go wrong in marking, you will not be able to get the section points properly. So friends, I will just start with marking A, B, C, the three sides. So after marking in the top view, I go to the front view and mark here this corner as A dash, B dash, and this is C dash. So A, B, C, A dash, B dash, C dash. Similarly, for the bottom face, you have to mark this as A1 dash, B1 dash, C1 dash. Then coming back, this will be the longer edge A1, B1, and CC1. Friends, we have marked all the corners and the heights of this object. Now it is resting with one of the side AB perpendicular to VP. And now we have to mark the cutting plane or section plane. He says in the question that the solid in this position is cut by a section plane which is normal to VP, means perpendicular to the board, bisecting the axis, meaning that it is going to divide this axis which has got a height of 70 mm into two equal parts. So this is going to be 35 mm, 70 by 2. And the section plane should pass through this, cutting the solid. So I am going to draw a line here, passing through this and inclined at an angle of 45 degrees to the horizontal. So this is how I mark the section plane SS. And friends, here this is making an angle of 45 degrees with the XY line or with the HP. So friends, after marking, see whatever the procedure I am telling, it has to be followed in the same way. After getting this, let us see what is the portion of the solid that is thrown out. So once the solid is cut into two parts, the upper part is thrown out and you are left with only this part below the section plane. So I am going to darken that part that is retained for the purpose of section is shown in color. Friends, here now what happens, let us see which are the points where the solid is cut by the section plane. This section plane SS, which is bisecting the axis of the solid, cutting the two longer edges A and BB at this point. CC is cut at this point. Now we have to obtain all these points in the top view to obtain the sectional top view. How to obtain them? Friends, see here, this longer edge is A and also BB. So both are cut here. So you get a point here for A a point here for BB. And the same line for the CC longer edge, you get one more point. After obtaining these points, friends, whatever the points you have got, you have to name them either in the clockwise order or in the anti-clockwise order. So I am going to mark it as 1, this as 2, and this as 3. After marking here, go to the front view. This is 1, 2, and this is going to be 3. 1, 2, and this is 3. They should tally. Friends, after joining all this by straight line, I am going to hatch it or section that 1, 2, 3 by lines drawn at an angle of 45 degrees to the horizontal and providing a spacing of around 2 millimeters. So, friends, here we have got a section part in the top view and we call this as sectional top view. This is sectional top view because we have sectioned the top view here. And in the front view, this portion that is removed is to be shown by thin lines and this has to be shown by dark lines. Portion below x should be dark lines, above there should be thin lines, but we have to retain that. Friends, this will give you the front view of this order, FV. Now friends, after these two, we have to obtain the true shape of the section. What is the meaning of true shape of the section? It is nothing but a photocopy of this cut section or a mirror image of this section. Friends, what is to be done for that? It is very simple. We are going to draw a line parallel to SS at any convenient distance to the gap depending on the place of it. So friends, I am going to draw a line here. This line is parallel to SS and I am going to draw perpendiculars from all these points, point 1, point 2 and point 3. So friends, I am going to draw a line here, another line to this point. So these lines are parallel and this is perpendicular to that I have drawn. Now I want to see how does the cut portion of this prism look when a mirror is cut parallel to the surface. The mirror image is itself the true shape. Friends, for obtaining this point 1, 2, 3 here, I should take the distance of 1 from xy to this one, transfer here. So this distance I have marked here is this distance. Then the same xy to this is the point B. Friends, so obviously what happened? This is point 1, this is point 2, and very obviously the distance between 1 and 2 is very obviously 30 mm. So that you are going to have. Friends, after obtaining this, let us obtain point P. This point P lies here. So we have to measure the distance of point 3 from xy and mark it. Friends, you are going to get it here. Say that is point 3. So 3 points you have got. Join all those points by straight line. So I have joined this by straight line and I have to hatch it at an angle of 45. Section it and hatch it at an angle of 45 degrees to the horizontal, and this part will give you the true shape of the section. TS stands for the true shape of the section. Friends, they have also asked you the question, what is the name of the true shape? Friends, this true shape, it has got a dimension of 30 here. It is a 3-sided figure. So it's obviously a triangle, and this triangle is an isosceles triangle because this has got this height, base is this much, height is this much. And also remember, whatever the height we get here is equal to this. Whatever dimension about is equal to that. And whatever the dimension 1 to 2 you have got is the same. So if you remember that, that will help you to solve some more problems at these. Since we have obtained the sectional top view, we have obtained the front view, now we need to obtain how does it look in the side view. That is, how does the section part of the solid look in the side view, or the end view, or the profile view. Friends, here I am going to draw a line here. I will call this as x1 y1. This line is xy, and I am the side view or left hand view of the solid or left profile view of the solid, assuming that the solid is not cut by any section plane. So for that, I am going to draw a line here at an angle of 45 degrees and transfer all these obtain the side view. How to obtain is very simple. Let us start with the edge AA. From AA, draw a horizontal line. It will meet here, project upward. So from a place you get a horizontal line. So this is going to be the NA. So in the side view, you show it as A double dash. And for the bottom part, we will call it as A1 double dash. So we put double prime for all the end views and the side view. On the same lines, friends obtain VB. So VB, same procedure you have to follow. And you will get this point B double dash, and this is B1 double dash. So these are the edges. Similarly, friends, when you are looking from the left end to obtain the left hand view, so let's say E, in the left hand view, what happens? This portion, the edge CC of the solid, that is to say, you are keeping the object like this. So when you look from this side, this particular edge which is behind this rectangle is not visible, and hence I have to show that by dotted line. So I follow the same procedure, obtain the edge, and that edge has to be shown by a thin line or dotted line here. So friends, this is the top face, this is C double dash and C1 double dash. This is the left hand view of the solid without the section plane. That is, we are assuming it is not cut till now. So friend, after obtaining this end view of the triangular prism, we transfer all these points 1, 2, 3 from the vertical edges A dash, A1 dash, B dash, B1 dash to the corresponding points in the end view. That is, to say I am starting with this point 1. 1 is on AA. So I take a horizontal line till AA. I get a point here. That point is 1 and on. Friends, on BB you want to find to extend that till BB. So this is point 2, we will say point 2. And friends, point 3 is on CC. Extend that till that. And we will get this point here. That point is going to be 3. So point 1, point 2, point 3. Join all these by straight lines for all the prisms and pyramids, including the cubes and tetrahedrons. So I am going to join by straight line. So I get this. This is the section part, how it is in the view. I am going to hatch it by lines inclined at an angle of 45 degrees to the horizontal. So after getting this, let's see which portion of the solid is retained in the end view. Friends, just look at the front view. In the front view, the portion from 1 to A1, this colored portion is retained. So I am going to show it. So this height is equal to this. Similarly, this height from 3 to C is also there, but that is not visible. Show it by a dotted line. Finally, 2 to B1 is also available, and the bottom portion of the prism is not touched by the section plane. Hence, you have to retain that. Friends, this will give you the left sectional end view, left sectional end view, or left sectional profile view, or left end view in section. And this is how we obtain the sections of the triangular prism. Friends, I hope you have followed the procedure, and I thank you very much for watching my YouTube video.